Okay, I'm going to attempt to give you an answer to this question using some specific examples. All right. And remember that if you're using the washer disk method, your typical rectangle is perpendicular to the axis of revolution. And if you're using the shell method, your typical rectangle is parallel to the axis of revolution. So case one, the choice is really yours, and it's not too bad either way. So if I have f of x equals x squared, that's this right half of this parabola, because I've got x greater than or equal to 0. So if I want to revolve this purple region around the dashed line x equals 4, I can use either method. If I use the shell method, this typical rectangle will be parallel to the axis of revolution, and I need to know the height of this shell, which will just be x squared, and I need to know the distance from the axis of revolution to the center of that shell, which we call the average radius, and that would be 4 minus this distance is x. It's actually the x coordinate at the left. 4 minus x. So there's the integral that will give you that volume. If I want to use the washer method, or the washer method in this case, my typical rectangles are perpendicular to the axis of revolution. And I'm using outer radius squared. Well, I need to get x in terms of y right here. X equals the square root of y. That's not too bad. Y to the 1/2 power. So the outer radius from the axis of revolution is this guy right here. 4, the x coordinate at the right, minus the x coordinate at the left. Well, the x coordinate at the left is the square root of whatever y is. That's what this is. And that's so there's the outer radius squared. The inner radius is 4 minus 2, which is 2 squared, or 4. And of course, multiplied by pi. So you can see I get the same answer either way. Setting up the definite integral and finding an antiderivative, not too bad. Case 2. What if you got no choice? What would that be? Well, x squared plus sine of x. That's this curve right here. Let's say I'm going to revolve that about the x-axis. Well, I've already got y in terms of x. So the height of the shell is x squared plus sine of x. I just need to square that, which is what I've got right here, dx from 0 to 1. I've got all these typical rectangles going from 0 to 1. But if I wanted to use the shell method, I'd have to have a formula for the height of a typical shell. That's this distance right here. I need to be able to solve this for x in terms of y. You can't do it. So you're forced to use, in this case, the disk method. And finally, to give you another example, choice is yours, but really, are you going to use one over the other? So if I've got this parabola, x squared minus 2x plus 3, bounded, one of the boundaries is that parabola. The other boundaries are x equals 0, x equals 2, y equals 0. So the green region, if I'm revolving that about the line x equals 4 again, if I use the shell method, there's a typical shell. And the formula for the height of that shell is the same every time. It's f of x, or x squared minus 2x plus 3. And so there would be the integral right there. The height of the shell, the average radius would be 4 minus x, because this is x right here. The average radius would be the x coordinate at the right minus the x coordinate at the left. That's the average radius right there. Not too bad. But if you're going to use the washer method, it's horrible. Okay, you can do it, but typical rectangle, well, there's one shell, there's another shell. I've got to separate this into 3 different volumes. One for, I'm going from 2 to 3 along right here. 2 up to 3, and I'm going to revolve this region about x equals 4. The outer radius would be 4 minus 0. 4 squared is 16 minus the inner radius. Well, hey, look at what I did up here. I went to all this trouble to solve for x in terms of y, and that's where these functions come from right there. You can do it using the quadratic formula, but the work involved would be ugly. And of course, volume 3 is just going to be a cylinder with a hole in it. All right, but there's proof that you can do it. You can get the same answer, 87.96, 87.96. Okay, so basically, you need to draw a graph of the function and find out what you're revolving around to decide what to do. There you go. Hope that gave you some help. And if you have any questions, post a comment.